calculation and comprehensive calculation. Okay. I will make like this. We have 5 multiple choice, each of them 2 points, so 10. 2 simple calculation, each of them 5 points, 10. And 2 comprehensive calculation, each of them 10 points, 20. So together, so it's 40 points test. Okay. The difference between the simple calculation and comprehensive calculation is usually simple calculation. Usually, it's just one stage calculation. Okay, more straightforward. And multiple choice, of course, there are conceptual problems. Okay, so any question here? Okay, and by the way, the problem will come from, you need to review all the examples and homeworks. Please note that you have homework set posted on the blackboard. That's a very important thing to prepare for the test. Okay. The test problem will not be the same as class example. They are just example. Okay. In fact, should be quite different. I got students complain that test problem too similar to the example, too easy. No, I do get the complaint like that. And you know, I have to respond with this kind of problem because that's very dangerous for my career. Usually, if student complains too difficult, it's okay for me. The department wouldn't mind that. But if student complains too easy, that's a trouble for the instructor. Okay.
Sorry, everybody. No, just kidding. Just kidding. Austin, quit doing that.
Of course. I don't know why they have to complain about that. That's a good thing. Yeah, not to say it.
We don't think that.
No, we think that you should stick with how you did your exam in 1370.
Okay. So the format was similar, but of course this is a higher level class, so of course it should be more difficult than that.
So is it just going to be 40 points, or are you going to count and double and make it 80 points?
40 points. Okay, finally, I'm just going to calculate everything in percentage. So 48 to 100, it doesn't make any sense. Any other question?
Did he just admit it doesn't make any sense? Yeah, okay.
Okay, so let's look at this problem. You have inclined plane like this. You have mass 1, which is 3 kilograms on the inclined plane. It's a frictional plane, so you have frictional force. Another one is hanging here with mass M2 equals to 2 kilograms. The coefficient of the friction, I give you both, the static friction 0.6, the kinetic friction 0.2. Remember that the kinetic friction is always smaller than the static friction coefficient. Okay. We want to find the magnitude of the acceleration for the following situations. Block 1 initially at rest. Block 1 initially is moving upwards. Block 1 initially is moving down. Okay. So first I would like to ask you, question A, B, C, when they have this different situation, what they actually affect? Which force is actually affected by this different situation? Frictional force. Other forces will be the same in all the situations, right? The friction, of course, will be different. in situation 1, what kind of friction do you have? Static friction. And by the way, do you know the direction of the static friction in this case?
Up the ramp.
In fact, it's hard to say at this point. It depends on the computation of the two weights. Okay. M1 is larger than M2, but of course M1 is on the inclined plane. So it will contribute only part of its mass in competition with M2. So it depends on the angle, which contribution is larger is still in question. But it wouldn't make any trouble for our calculation. In our analysis, you can assume some direction of the frictional force. And finally, you will get either a positive or negative force. That will indicate the actual direction of the frictional force. It doesn't really matter. And part B and C, of course, it will be the kinetic friction. And in the two cases, you can directly determine the direction of the frictional force, right? It will be, in this case, frictional force will be downward. In this case, frictional force will be upward. Okay. So that's some quick analysis. Any question here? Okay. Let's see situation A. This is M1. This is M2. Okay, what is the angle? 37. Okay. Okay, let's see. In the first situation, the block 1 initially at rest. So you want to consider some static frictional force. We want to find the acceleration. So basically, in this part, okay, in fact, part A is more complicated than part B and C. B and C are very straightforward. Part A, whenever you have to deal with static frictional force, there is always a problem that you need to determine the actual static frictional force and determine if it, so it depends on if the external pulling force actually can be larger than the maximum static frictional force. Okay. So you want to calculate both, in this part actually you need to calculate several things. You first need to calculate maximum static frictional force. And also you want to calculate the forward force. Let's call it forward force without friction. And compare the two, okay, which one is larger or smaller. Okay, you need to determine it to be larger or smaller. And then you can determine the actual static frictional force. It will also give you then you can get the acceleration. Okay. So let's look at how can we determine these forces. Maximum static frictional force can be calculated as mu s multiplied by n, right? Okay. Mu s is 0.6, n is this normal force. You have to be able to calculate it from the force analysis. Please note that in this case, of course, it's not mg. Okay? You have m1g here, you have n here, and you have some tension T here. Okay? And for this one, you have tension T here, and you have M2G here. I think that's all the forces, right? Okay. Initially, it's at rest. So let's determine the forces. Okay, so we need to, in this case, we have to decompose the weight for the object 1, Wm1g. So we will get this force and this force. Okay, this we can call Wx, this is Wy. Okay, Wx should be M1g, the weight, multiplied by sine or cosine. Sine 37. This is also 37. Okay. So Wy should be M1g multiplied by cosine 37 degree. Now, if we do the force analysis, okay, so for this object, okay, so initially it's at rest, so we assume, okay, so we do the analysis for at that moment, so acceleration equals to 0. Let's check the force balance, okay. So we get that for this object, we should have T minus Wx equals to, it's not like that. We still have friction force, okay. Okay, we look at this. If it's initially, we first ignore the frictional force. Okay, we can think about, you first have this force, and once it's trying to move, it will introduce the frictional force. So with these forces, what happens is that you can compare the T here. You can put T for M2G. Okay. Subtract Wx, what do you get? Let's calculate the number for M2G. What is M2G? 2 times 10, 20. Let's use 20. Okay, 10 for G, 20 Newton. And let's calculate Wx. What's that? Okay, Wx equals to M1 multiplied by G, 30 multiplied by sine 37. Okay, what's the number for this one? What do you get for this number? M1G sine 37. 18? Okay, this is 18 Newton. And what's this? Is that 18? 30 times 0. Yes, this is
12. 24.
24 Newton, right? Okay. So Wx equals to 18. This one equals to 24. And this tension, if it's equals to this, it gives 20 Newton. So, in fact, this will determine the direction of the static friction. Okay. The tension T is 20 and this force is 18. So that means the tension T is larger than Wx, so it will pull to that direction. So the frictional force has to be in this direction. Okay? This is the static frictional force. What is the static frictional force here? 0.6? Static frictional force. 0.6 is just a coefficient.
0.6 times n.
It may or may not. Okay. Fs max is that. So what actually happens is that There are two possibilities, in fact, from this analysis. One possibility is that you have 20 here, you have 18 here. Friction force can be just 2 Newton to compensate that, right? Another possibility is equals to Fs max. But you need to determine the 2 Newton and Fx max, which one is larger, which one is smaller. It should be the smaller one, right? Now let's calculate the Fs max. It's 0.6 multiplied by n. According to our analysis here, n minus wy should give you 0. So n equals to wy equals to 24 Newton, right? Okay. So multiply by 24. What is static frictional force here? So this is the maximum static frictional force. So after the calculation, what is the actual static frictional force? 2 Newton, okay. Any question here? And what is the acceleration? Zero, okay. Any question here?
How did you figure out the magnitude? How did you figure out the mg?
mg mass multiplied by the gravitational constant, 10. So if 2, mass is 2, the weight is 2 times 10, 20.
What did you get the 2 from? The constant is 10.
G equals to 9.8, roughly 10.
Oh, it always will, no matter. It will always equal to that?
Yeah, G is a constant.
Okay.
If you are on the Earth's surface, it's always that number. Question?
What did the 2 comes from?
This 2, okay, is T minus Wx. Okay, so here, I don't know if you get a little bit confused because the calculation is simple, but it involves some thinking about that. So the key here is try to identify. So the system can provide you up to 14.4 Newton static frictional force. So it's try to see if the system only requires some force less than 14.4, and if it that can reach equilibrium, the system will stay in the equilibrium, okay, with 0 acceleration. So that means it will not move. The M2 is not large enough to pull it downwards. And in that case, the actual static frictional force will only be the force enough to compensate the external forward force, or just to make it stay there, right? So in that case, you can see that without frictional force, this is 20 Newton. The M2 will provide 20 Newton forward pulling force. And this side, you have Wx, which is only 18 Newton. So it will have the difference 2 Newton, right? And of course, the system can give it 2 Newton frictional force to make it stay there. And opposite situation, a contrary situation, is think about if you have very large mass of M2. Say, if M2 equals to, let's say, 100 kilograms, we give it a very large mass. Of course, it will move. In that case, what happens? Then the tension provided by M2 will be 1,000 Newton, right? If it's 100 kilograms. If it's 1,000 Newton, so that means to compensate the external pulling force, you need 1,000 minus 18. Okay, which is 982 Newton. You need 982 Newton frictional force to stable it. But of course, you can have only 14.4 Newton frictional force. Okay, so in that case, if this is the case, then the static frictional force will be exactly 14.4 Newton, and the acceleration will be calculated by this tension T, which is 1000 minus this 18 and minus this 14.4 divided by the mass. 1. Okay. Any question here? So this is the situation of the static frictional force. Okay. Now, let's look at part B. You have any question part A? Okay, you can go back to think about that. Consider very small mass, like 2 kilograms, or you can even think about very small mass, and consider a very large mass. What happened in the two situations? That's a key to understand the static frictional force. And B, for kinetic frictional force, okay, it's actually much easier. Now, in this case, the block 1 moving up, so it's already moving, so you have the kinetic frictional force. And kinetic frictional force has a definite direction and definite value. So you don't have to decide it. Okay. So this is the frictional force. This is the normal force N. This is tension T. This is W1. Okay. Here you have tension T at W2. That's a force analysis. First, do you have any question about these forces? The existence of these forces. Frictional force, okay. Tension, normal force, weight, tension, weight. And again, you have to decompose the weight to get Wx, W1x, W1y. And similarly, W1x will be 18 Newton, right? W1y will be 24 Newton. And W2 will be 20 Newton. Okay, this will not change. And here, you can write down the Newton-second law for different directions to determine these things. For M1, you have two equations along x direction and y direction. So it will be, if we choose positive direction, like this. So along x direction, you have T minus W1x minus frictional force equals to M1AX. Okay, this is positive x. And then you have N minus W1y equals to M1AY. Okay, A1x and A1y. That's the two equations for M1. And for M2, if we call this is positive x direction, okay? If we call this is positive x direction, it has only one direction. There is nothing happen along horizontal direction. So we can get equation called W2 minus T equals to M2A2X. Okay? Any question about these equations? Please check all the terms and their signs. Make sure you agree with me why I put these terms and why I put them with positive and negative sign. Please note here is T minus W1x. This is W minus T, okay, due to the positive direction like that. Is there any question for what?
Is that A2X?
Yes, I said A to X because I call this is X direction. Okay. You can call it Y direction or X direction or even Z direction. It doesn't really matter. But you need clear about your own naming. Okay. Any question here?
Why are there two different types of acceleration? Wouldn't the whole system just have one acceleration?
Because I first write down the original one, and then I will identify they share the same acceleration. Okay. So I think this is good because it's good you do it step by step. So at this time you are not bothering identification of the acceleration. Just write down its most original form. Okay. Any question here? And then of course we should be able to identify the acceleration. So what do we know about acceleration A1y? The acceleration along this direction. 0. So A1y equals to 0. And then what do we know about A1x and A2x?
They're equal to A.
They should have the same value, and we can call this value is the acceleration for the system A. Okay. So then you write it as T minus W1x minus, please note this is a kinetic frictional force. So it can always be written down as mu s multiplied by n. Okay. This is a good thing about the kinetic friction. It always can be written down as this, but static friction force is not. That's true.
Is that 2A1X?
Yeah, it's a typo with the
Oh,
A's.
that's over the Y.
A1x plus equals A1x. All the way on the right.
At the top.
All the way on the right on the top.
When you talk about
No, right there.
Okay.
That should be UK, correct?
Hmm?
Is US in that, or is it supposed to be?
UK. Any other type? Okay. So equals to what is it here? M1A. And this equation becomes n minus W1y equals to 0, right? And this equation becomes W2 minus T equals to M2A. Okay? Now, you have three equations. You can further write them. So you get T minus W1x. Can you tell me what's W1x? Is it 18 minus mu s mu k? Mu k is 0.2 and equals to m1 is 3a. Okay, and then you have n minus W1y. What's W1y? 24 equals to 0, and you have W2. What's W2? The weight 20, okay, minus T equals to M2, which is 2A. So actually you have this kind of equation. You have three unknown quantities, you have three equations. So you can solve for it. It's quite simple. This one can directly give you n equals to 24. And if you substitute to here, you get t minus 18 minus 0.2 times 24 is, what's that? 4.8 equals to 3a, and 20 minus t equals to 2a. So you get these things, right? This one is okay, and then you get the two equations you can solve for a and t. The most simple way, like say, you get from this you get p equals to 20 minus 2a, and substitute here you get 20 minus 2a minus 18 minus 4.8 equals to 3a. So you can get a, and substitute here, you can get t, right? Any question here? So you can finish these calculations after that. It's just math. So the most important thing here is to understand what we are going to do for each state. Why should we do that for each state? Any question here? Is clear every state what I'm doing here? Okay. So now, for another situation, okay, when you have the system moving downwards, so you get something like this. W1 and T and Fk is in this direction now, right? Again, it has a definite value, mu k multiplied by n. And this one, you still have T minus W2. Okay. So almost the same, okay, all the procedures. And here, let me just do this. Okay. Can you, by looking at this equation, and tell me how to write down the three equations for this situation? Just modify that. Okay. Because you know it should be almost the same, so there will be only a little bit modification. How do you modify this equation to get the three equations you need here?
You change the sign?
Okay, so which part will be changed?
The first.
In fact, it will only change the sign for some forces, right? Okay. And you can see which one will be changed. So it will be T minus W 1x plus Fk mu Kn equals to M1A and N minus W1 equals to 0. And W2 minus T equals to M2A. So the only change is here. And of course, by doing that, there's another thing I have to note. In this case, you probably will get a negative acceleration, okay? Because we use this kind of positive. But in this one, in fact, the best positive should be like this. So if you use these things, you may get a negative acceleration, but that's fine. You can do this by yourself, right? Any question here?
The positive x is going upward. You said you switched it.
For this one, I didn't. It's still like this. Okay? And if I switch positive x in a more make sense way, like this, okay? Positive x and positive x because they are moving this way, right? And then what I'm going to have, I should have negative t plus w1x minus mu kn equals to m1a. And n minus w1y equals to 0. And t minus w2 equals to m2a. Okay, so if I use this kind of positive, then all these forces will change sign from here. You can go back to the force analysis from the beginning and write down these 10 terms. You can check that. Okay. I think these are good exercise help you to keep track with different coordinates. In different coordinates, how do you put size correctly? In fact, I would say usually they are the key issue for the problem solving. After that, equation solving is not the key for us. Okay. Now let's look at this one.